Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily lead code problem, and the problem's name is product of array except self. So the problem statement goes like this: given an integer array nums, return an array answer such that answer each entry in answer is equal to the product of all the elements except the number present. Okay, let's say there is a let me describe this problem in my own words. Okay, so there will be an array given to you, nums. There, let's say there are some indices in this array, 0 to let's say n minus 1, and nums is of n length. So you have to return an array also, and that will be the answer array. Okay, now every entry at a particular index should contain the product of all the numbers except the number at that index. Okay, so let's say at a particular index in this answer array, the entry will be equal to product of all the numbers in the given array nums except the number at this particular index. Okay, so for example, this one is the array that is given to you, and if we mark the indices also 0 1 2 and 3, and what is the overall product? 24. So except 1, what is the product? Still 24. Except 2, what is the product? 12. Except 3, what is the product? I mean 2 and 4, 8. Except 4, what is the product? I mean 1 2 and 3. 3 into 2 is 6, so 6. So this is what the program statement is asking you to return, and it is mentioned that product or prefix of the nums array is guaranteed to fit in 32-bit integer. So what is prefix and suffix of nums array? Prefix can be anything that is starting from beginning. Okay, it can be this, it can be this, or it can be this also. Okay, anything starting from the beginning, any segment. Or suffix, what will be the suffix? Suffix will be anything starting from the ending. Okay, it can be this, it can be this, this segment is also valid, this segment is also valid. Okay, so these are suffixes. You must write an algorithm that runs in linear time complexity and without using division operation. Okay, otherwise it would have been really easy. You would have just have to divide every number by 24, which is the overall product. Okay, so you do not have to use division operator, and you have to run you have to write a linear time complexity algorithm. Okay, and let's have a look at the constraints. So the length of the array will be of order 10 raised to power 5, and all the elements are ranging from -30 to 30. And it is mentioned that the prefix and suffix of nums array is guaranteed to fit into 32-bit integer, so we need not to take care of any overflows here. Okay, so can you solve this problem in order of 1 extra space complexity? There is a follow-up also, and it is mentioned that the output array does not count as extra space for space complexity analysis. So we can leverage this fact. How we can leverage this fact? What we can do is we can form a suffix array. Okay, suffix array. it will be the array that we will be returning, so it will be not counted in extra space. So we are leveraging this fact that output array space will not be counted in extra space. Okay, so this is what we will be returning at the end. Anyways, suffix array will be something like initially you will be starting for the very first index, you will be starting with the number as it is, then product goes on. Okay, like 4 into 3 12, and then 12 into 2 24, 24 into 1 24. Okay, this will be your suffix array. And once you form the suffix array, what you can do is you can then run a linear loop over this array and have a variable called prefix product. Okay, initializing it with 1, then with each element that you will visit from left to right direction, what you will do, you will simply exclude that element and see what is the suffix array entry in the very next index. Okay, what I mean by this is let's mark the indices first in the suffix array. So let's say you are visiting index 0 in this nums array that is given to you. Okay, so then what you will do, you will see what is the entry in the at the index 1. Just let's say this is your current index, so you have to check what is the entry in current index plus 1 in suffix array. Okay, it's 24. Then you will take 24, and whatever is the prefix product value, you will multiply it with 24. Okay, so prefix product is initially set to 1. Now you will multiply it to 1. Okay, so now moving further, your prefix product will be 1 into 1. After this operation, you have to update the prefix product. It is very important that after this operation you have to update your prefix product, not before this operation. Okay, so instead of 24 here, what you will, okay, it will be 24 only here. Then you will be moving to next index. Okay, so let me change colors here. So you will be moving to this index. You will this will be your current index. So current index plus 1 is 2. So the entry in suffix array is 12. And what is the value of prefix product? It is 1. Okay, 12 into 1 will be 12. Okay, so instead of 24 here, what you will write? You will write 12. Okay, and once you are done, once you are done, updating your suffix array, then only you will update your prefix product, which will be 1 into 2. So your current value of prefix product will be 2. Okay, then you will be moving further. So you will be here, then it is the current index. So current index is 2. 2 plus 1 is 3. So your new product is at index 3. What is the value of suffix array? 4. And what is the current value of prefix product? It is 2. Then what you will write? 8. So for the second index, your value will be 8. Okay, now once you have done updating the suffix array, you will update your prefix product, which will be 2 into 3 is equal to 6. Okay, now you are at the very last index that is there. So this index, so there is no further index in suffix array. So for that, what you will take, you will take 1. Okay, so 1. And what is the current value of prefix product? It is 6. 1 into 6 is equal to 6. So you will update this, and although you are at very end, but you can anyways update your prefix product after this updation of suffix array, which will be 24 here. Okay, so this is how we will be approaching this particular problem. Now let's quickly do the implementation. Okay, and space and time complexity wise, since we were doing only 2 linear traversals here, so space complexity wise it will be time complexity wise it will be order of n, where n is the size of nums array that will be given to you. And space complexity wise it is mentioned that output array does not count in extra space, so we are just using constant extra space as per the problem statement. So let's do the implementation quickly. So first of all, you should be knowing the size of the nums array that is given to you. Okay, so now once you have known the size of the nums array, what you will do, you will form a suffix array. Okay, of same size. Okay, and then you will do a linear traversal, but from the back. Okay, index will be from size -1, and index should be greater than -1, and then index will be increasing at each step, decreasing at each step, since we are going from right to left. So if index is equal to the very last index, then you will simply retain the value of nums at that particular index and do nothing else. Else if that's not the case, then let me write suffix array here, not suffix. Okay, then suffix array, current index will be nothing but current value of at nums, which will be the entry at this particular index, and value of suffix array at one previous index, so index +1. Okay, and yeah, so once you have done this, you will be having your suffix array. Then what was the next step? Next step was doing a linear traversal with a variable prefix product. Yeah, prefix product. Initializing it with 1, and then you are just doing a linear traversal. So for linear traversal, I don't think we would be we would be requiring the indices, so that we would be knowing what is the next index in suffix array. Anyways, doing a linear traversal from left to right here. So what will be the updated value? It will be nothing but current state of prefix product into whether you will check index +1 should be less than the size of the array, and if that's the case, then you are fine, and you would be taking that index in suffix array. So suffix array index +1. Else what you will do, else it was the case when you are at the very last index, you will just take 1. Okay, so yeah, and then what you will do, you will update your suffix array. So suffix array at this particular index will be nothing but updated value. Okay, and then you will do what? You will just update your prefix product. Okay, and just returning your suffix array would be sufficient now. Since we have done all the work that was required. Prefix product, yeah, it should be fine. Okay, so let's try to submit for the sample test cases. Yeah, as you can see, it's getting accepted. Let's submit for the final evaluation. Yeah, as you can see, it's getting accepted for final evaluation also. So that is how we will be solving this particular problem, and these will be the complexities. Okay, and yeah, if you are still having any doubts or any queries in general, feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.